Number three condition is going to be if 0 less than or equals x less than 1 or so that's the problem. Of writing because you look at here on the screen. Okay, so I'm going to repeat. So we finished two conditions. So there are 10 conditions. One condition is going to be this area, entire this area, and the other 9 conditions will go through because we have 1, 2, 3, 1, 2, 3. There are 9 conditions. So total 10 conditions. So when we fix x, we vary y from 0 to 1, okay, 1 to 2, and greater than or equals to. And when we fix, and then again what we do, we go from 1 to 2, x condition 1 to 2, and we vary y for these 3 conditions. And that's the philosophy that we are going to follow. You guys understood? So total 9 conditions, total 10 conditions. One condition we put, we placed it using yellow color right here. And the other 9 conditions, because it has 3 values of x, 3 values of y, so 3 times 3 equals 9. So so that you are able to follow what's going on. So I'm just trying to explain from high level point of view, what is my philosophy to go through all these conditions. So I fixed x condition 0 less than or equals x less than 1, y 0 less than or equals y less than 1. So I fixed this x condition 3 times, but y condition is going to vary. So next condition is going to be 1 less than or equals y less than 2. You see that? You see that? So this condition. So once you have this condition, then your joint CDF f sub x comma y taking value x, y, and by definition, it is probability that x less than or equals x comma y less than or equals y, and the only values of x and y from these conditions fall are here x equals 0, right? From here you see x equals 0 because number of packets cannot be fractions, so it's x equals 0. And because y goes all the way from negative infinity to y, and if you look into this condition, so y equals 0 is there and y equals 1 is there. So that's why you see that joint PMF of random variable x comma y taking value 0 comma 0 plus joint PMF of random variable x comma y taking value 0 comma 1. That's it. So now this is 1/4 plus 1/4 equals 1/2. Okay. So that you know what's going on for again 7 conditions. So you see x less than or 0 less than or equals x less than 1, and 1 less than or equals y less than 2, it is half. So what you are going to see in my 3D plot, so x I varied from 0 to 1, guys, and y for this condition it's 1/4, but 1 to 2 it's accumulating. It's accumulating 1/4. 1/4 is going to be 1/2, and this is the part that I'm talking about. Okay. So graphically, you show the joint PMF as such. You will have one homework example where you will draw these 3D blocks. Okay. So, but try to understand so that you know what's going on. There are many libraries available already. You just make use of libraries, but you know the theory behind it. That way using libraries, it's going to be a piece of cake. You don't have to write functions completely from scratch. You just call, but you have to know what's going on. So this is 1/2. So that it is coming from right here. The way we defined the joint PMF, and then we got the joint CDF on this under this condition. Okay, number 4 condition. Fourth condition is I fix. Still we have if 0 less than or equals x less than 1, and this time y greater than or equals 2. So we get this condition. So this condition, for this condition, what do you see? You see x equals 0, y equals 0. X equals 0, y equals 1. X equals 0, y equals 2. So for this condition, you get all the x and y values that I talked about. So f sub x comma y, taking value x comma y, by definition it is probability that x less than or equals x comma y less than or equals y. Okay? So now all the values that you get, even though it's a y greater than or equals 2, you don't care for y greater than or equals 2 because y, value of y can be maximum 2. So you have joint PMF of random variable x comma y taking value 0 comma 0 plus joint PMF of random variable x comma y taking value 0 comma 1 plus joint PMF of random variable x comma y taking value 0 comma 2. That's all. So now you know what was joint PMF of 0 comma 0? It was 1/4 plus 0 comma 1, it was 1/4 plus 0 comma 2, what was that?
160.
160. And this will give you 9/60. And I will not show my 3D plot. You will see that it is 960. It's little above this half. Number fifth condition. Fifth condition is, now I finished all the y conditions for fixed x conditions. Now I'm going to go through this condition. X 1 less than or equals x less than 2. Now y will vary for 3 other conditions. So if 1 less than or equals x less than 2 and y, I start from 0. 0 less than or equals y less than 1. Okay. So now what do you see here from this condition? You can get 0, x0, x1, and you get y0. So x0, 1 and y0. That's all. That's all you get. So your joint CDF, f sub x comma y taking value x comma y, which is by definition probability that x less than or equals x comma y less than or equals y, and you get joint PMF of random variable x comma y taking value 0, y 0, 0, 0, plus joint PMF of random variable x comma y taking value 1, 0, 1, 0, and you see that it is 0 comma 0 is 1/4 plus 1/4 is going to be 1/2. Okay, and you will see that 1/2 that surface is on the other side of my 3D plot. So number sixth condition is if 1 less than or equals x less than 2, comma 1 less than or equals y less than 2. So the numbers that you will get, x and y numbers, you get 0, 1, here you get 0, 1. So joint PMF of random variable x comma y taking value x comma y equal by definition, it is probability that x less than or equals x comma y less than or equals y, and you get joint PMF of random variable x comma y taking value 0 comma 0 plus joint PMF of random variable x comma y taking value 0 comma 1 plus joint PMF of random variable x comma y taking value 1 comma 0 plus joint PMF of random variable x comma y taking value 1 comma 1. So 1, 2, 3, 4. So there are 4 components of joint PMF, and from joint PMF table we know that it is 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1 was, how much was it? 1. And this should give you, make it multiply numerator and denominator by 2, so 2 plus 2 plus 2, 6 plus 1, 7, 70. So number 6 and number 7 condition is if 1 less than or equals x less than 2 and y greater than or equals 2. So this condition, you get 0 comma 1, here you get 0 comma 1 comma 2. X values are 0, 1 and y values 0, 1, 2. That's all you can get. So joint PMF of random joint CDF of random variable x comma y taking value x comma y, which is by definition probability that x less than or equals x comma y less than or equals y. Now you take joint PMF of random variable x comma y taking value 0 comma 0 plus joint PMF of random variable x comma y taking value 0 comma 1 plus joint PMF of random variable x comma y taking value 0 comma 2 plus joint PMF of random variable x comma y taking value 1 comma 0 plus joint PMF of random variable x comma y taking value 1 comma 1. That's it, right? Do you follow? Do you follow? Do you follow me, guys? Again, math is not hard at all. It's all about you understand the problem. So now I'm writing all these values. So this is going to be 1/4. So it is coming from joint PMF. So to find joint CDF, you need to find the joint PMF first. So here you have 1/4 plus 1/4. This is going to be 1/16 plus this is 1/4 plus 1 is 1/8. So this is going to give you 15/16. So as you can see, let's multiply by 4 numerator denominator. 4 plus 4, 8 plus 1, 9 plus 4, 13 plus 2, 15/16. Okay, so this is the 7th condition. Now 8th condition, number 8 condition, if x greater than or equals to. So this time, if x greater than or equals to, and you start y, 0 less than or equals y less than 1, this condition. So in that case, your x values are 0, 1, 2, and y values could be 0, 1. So joint PMF of random variable x comma y taking value x, y, which is by definition probability that x less than or equals x comma y less than or equals y. So which is basically you take all the PMFs, joint PMFs of random variable x comma y taking value 0 comma 0 plus joint PMF of random variable x comma y taking value 1 comma 0 plus joint PMF of random variable x comma y taking value 2 comma 0. So now you get the values from the joint PMF table. So this is 1/4 plus this is 1/4 plus this is 1/16, and this should give you 4 plus 4, 8 plus 1, 9, 16. So 2 more conditions, guys. Condition 9. Okay, if x greater than or equals 2. So we put the condition 0 less than or equals y less than 1. Now you take the middle term, which is 1 less than or equals y less than 2. So that way you get x values 0, 1, 2, and y values you get 0, 1 only, because it's 3 less than 2. So in that case, your joint PMF, joint CDF of random variable x comma y taking value x, y, which is by definition probability that x less than or equals x comma y less than or equals y, and which is joint PMF of random variable x comma y taking value 0, 0, plus joint PMF of random variable x comma y taking value 0, 1, plus joint PMF of random variable x comma y taking value 2, 0, 0, 0, 1, and let's start with 1. Joint PMF of random variable x comma y taking value 1, 0, plus joint PMF of random variable x comma y taking value 1, 1, plus joint PMF of random variable x comma y 2, 0. That's it. So now you will see this is going to be this one is 1/4, plus this one is 1/4, plus this one is 1/4, plus this is 1/8, plus this is 1/16, and this should give you 4 plus 4, 8, 12, 14, 15. So 15 over 16. Last condition. I thought that I should be able to finish by this slide, but I need to add. Last condition, condition number 10. If x greater than or equals 2 and y greater than or equals 2. So x values are 0, 1, 2, y value 0, 1. So in that case, you have joint CDF of random variable x comma y taking value x comma y, which is by definition it is probability that x less than or equals x comma y less than or equals y, which is basically joint PMF of random variable x comma y taking value 0, 0, plus joint PMF of random variable x comma y taking value 0, 1, plus joint PMF of random variable x comma y taking value 0, 2, plus you start with 1, plus joint PMF of random variable x comma y taking value 1, 0, plus joint PMF of random variable x comma y taking value 1, 1, plus you don't say 1, 2 because number of packets is going to be more than 2. So now only thing that is left is joint PMF of random variable x comma y taking value 2, 0. That's all. So 1, 2, 3, 4, 5, 6 elements, and all other elements are 0. So you have this is 1/4, plus this is 1/4, this is 1/16, plus this is 1/4, plus 1/8, plus 1/16. Guys, can you tell me what's this?
It's 1.
4 plus 4 plus 4, 12, 14, 15, 16. Yeah, it is 1. So now mathematically, if I ask you to write joint PMF mathematically, in compact form, you can write it as such. In compact form, joint PMF of random variable x comma y taking value x comma y equals, it is going to be 0. What's going on? It is 0, x less than 0 and or y less than 0. It is 1/4 if 0 less than or equals x less than 1 and 0 less than or equals y less than 1. And it is 1/2 when 0 less than or equals x less than 1, 1 less than or equals y less than. And it is 9/16 when 0 less than or equals x less than 1 and y greater than or equals 2. And again it is 1/2 when 1 less than or equals x less than 4, 0 less than or equals y less than 1. And it is 7/8 when 1 less than or equals x less than 2, 1 less than or equals y less than 2. And it is 9/16 when 1 15/16. So it is 15/16, 15/16 when 1 less than or equals x less than 2 and y greater than or equals 2. Now the last 3 is going to be 9/16 when x greater than or equals 2, 0 less than or equals y less than 1. And it is 15/16 when x greater than or equals 2, 1 less than or equals y less than 1. And it is 1 when x greater than or equals 2, y greater than or equals 2. That's all. So that concludes this example. So this is basically the foundation. Now, in most cases, you will not be working with just two-dimensional system. The dimension of your workspace is going to be more than, in most cases, it's going to be more than 2 dimension. So 3 dimension, 4 dimension, 5 dimension, 6 dimension, like that. Even like, if you work with quadcopter, a drone, for example, it works with 12 dimension. So X, Y, Z, roll, pitch, yaw, X, Y, Z, roll, pitch, yaw, and then their velocity. X-axis velocity, Y-axis velocity, and Z-axis velocity, and then angular velocities as well, 6 angular velocities. So 3 angular velocities, 3 linear velocities, and then 3 Cartesian coordinates and 3 angular positions. Okay, linear positions and angular positions. So total 12 coordinates. So in that case, you can see how it's going to be their CDF, joint CDF. It's much more complex, but in 3 dimensions, you can actually visually see. But after 3 dimensions, you just have to write your joint CDF mathematically, and then from joint CDF, you should be able to find the probability. All right. So if you want to take picture, you can take picture as well. So what I did, I actually, for you to understand, I drew 3D step surface. You see that? So all the quantities that we derived, like 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, and one region is 0. So we have 3D step surface to show the joint CDF of random variable x, y. Now what I did, I actually projected this 3D surface on 2D space. With different colors, I showed you like what are the values of joint CDF. You got it? So don't get confused with the second plot. So this second plot basically will show you all the conditions, because in 3D you don't see some numbers are hidden. okay? But in 2D, you can see all the conditions and their joint CDF if you project on the graph. So that is one part of the solution. In this example, so we found the joint CDF. Now we find the marginal CDF of x and marginal CDF of y. Marginal CDF of x, marginal CDF of y, it's a piece of cake once you know the joint CDF. So once you know the joint CDF, marginal CDF is basically one of the arguments is going to be infinity. Okay? So solution continues. Marginal, actually let me use different colors so that you may. Marginal CDF. Of random variable x. Okay? So for that, we have marginal PMF. We found the marginal PMF. Marginal PMF was marginal PMF of random variable x taking value 0. It was 960. In our previous class, we did go through this marginal PMF. So I just directly write the answer. And marginal PMF of random variable x taking value 1 is going to be 6 over 16. And marginal PMF of random variable x taking value. What's going on today? So marginal PMF of random variable x taking value 2 is going to be 160. So we will need to find marginal PMF of random variable x. I'm just going to write marginal CDF of random variable x. We generate it with f sub x, which is by definition it is probability that x less than or equals x equals what? For all values of x from the interior. Now we have here three conditions because marginal CDF depends on just x conditions and y can take any values. So we just have three conditions. If condition number 1, if x less than 0, then f sub x is going to be 0. Because number of packets destined to output port number 1 is negative, which is impossible even regardless of y. Therefore, your marginal CDF is 0. Now, so let's put condition number 1. Condition number 2, if 0 less than or equals x less than 1, then f sub x is by definition it is probability that x less than or equals x, and the only PMF that you see, only marginal PMF that falls in this condition, it is marginal PMF of random variable x taking value 0, and we found this marginal PMF 9 over 16. Okay? And then number 3 condition is if 1 less than or equals x less than 2, Then f sub x, which is by definition, it is probability that x less than or equals x is going to be, there are two values only, 0, 1. So marginal PMF of random variable x taking value 0 plus marginal PMF of random variable x taking value 1, because only 0 and 1 that can satisfy this condition of marginal CDF. So this you have 9/16 plus 6/16, which is 15/16. And final condition is if x greater than or equals to, then by definition marginal CDF of random variable x taking value x, which is by definition probability that x less than or equals x for all values of x. Now the values of x that fall under this condition is basically marginal PMF of random variable x taking value x plus marginal PMF of x taking value 1 plus marginal PMF of random variable x taking value 2. That's all. So which you get is this one 9/16 plus this one 6/16, and this guy is 1/16, and that should be the 1. So mathematically in compact form, you write f sub x, you write marginal CDF f sub x equals 0 when x less than 0, and it is 9/16 when 0 less than or equals x less than 1, and it is 15/16 when 1 less than or equals x less than 2, and it is 1 when x greater than or equals 2. And graphically, you show it like that. So this is your f sub x, and this is your x. Okay. So it is going to be, when x less than 0, it is going to be 0 all the way, not including 0. When x equals 0, so it is 9/16. So it is filled dot right here. So it is 9/16 all the way. So this is 9/16 all the way to when x equals 1, but not including 1. When x equals 1, so you go you go all the way to 2, but not including 2. So when x equals 2 or more, you get 1. So this is 1, and it goes like that. So this is going to be 1. Now this is your 2-dimensional plot. So make sure this circle with hollow is important, because when x equals 0, the value is going to be 9/16, not 0. So that is going to be the graphical representation of a marginal CDF of random variable x given the joint CDF. Okay. So similarly, I'm going to, as part of homework, I'm going to put similarly you determine the marginal CDF of random variable 1. Okay. I'm going to put this as part of the note, you will have to solve it. Okay. So, that is the complete solution of this example, and that example is the longest example in the whole chapter. Okay. So I will need maximum 2 50-minute sessions to complete the probability part of this course. Then we'll move on to statistics, which is chapter 7. Okay. So that concludes my today's lecture. Does anybody have any question? No? All right, then I will see you on Friday.